Okay, so in this one, we are going to talk about what's called even and odd functions and symmetry. Now, the first thing that I want to specify when we're talking about even and odd is that this is not a one or the other type of scenario. Functions can be even, functions can be odd, but functions can also be neither one. So they don't have to be any of this, okay, when this is all occurring. Now, I'm going to give the definitions, and then it talks about the symmetry of it. I'm going to handle those after we handle the algebra side of stuff, okay? So for an even function, we have that a function is an even function if f of negative x equals f of x. Now, algebraically, what this means, it's very much like function notation. Everywhere we see an x, we're going to plug in negative x, and then we're going to have to chase it through those sign changes, like negative, negative makes positive, and so on. And if we get back out the original function, then it's even. If it's an odd function, then we're going to get the original function, but everything's going to be switched in sign. You'll see as I go through the examples, this clarifies up just a little bit. And then we've got a couple of symmetries about stuff, and we're going to talk about that when it comes through. Okay, so I'm going to start with the algebraic side of stuff. Okay, so I'm going to go ahead and get this one written on my board, and then I'll switch. Okay, so we're going to, let me get this, we're going to switch. Okay, so we've got 7x to the fourth minus 3x squared plus 19. So what we're going to do is we need to do f of negative x. I'm going to move down here. So f of negative x is going to be 7 negative x to the fourth. And everywhere we see an x, we're going to replace it with negative x squared plus 19. Okay, so now we're going to chase some signs. So negative times negative is positive, times negative is negative, times negative is positive. So this is going to come out to be a positive item. A positive times a positive is still positive. So it's going to come out 7x to the fourth. Now, here, negative times negative is positive. That positive piece times that negative 3 is going to come out negative. So it's going to give me this. And then the 19 didn't have any x's on it, so it stays the same. Now, if this matches this, sign for sign, spot for spot, everything, and in this case it does, then this is an even function. And we're done, okay? This is kind of like driving down the highway. If I figure out that it's even, I'm taking the exit to Evansville, we're done with that problem, okay? If it's not even, then I have to keep driving, and I'm going to have to do a little bit more work. Now, the good news is that when you check, and you always start with even, okay? That's going to be the first thing that you always check for. So we're going to look at another one. So I've got g of x is going to be 4x to the fifth plus 12x cubed minus 9x. Okay, so this is what we're going to work with. So again, we're going to start with even. So everywhere we see an x, we're going to replace it with a negative x. Okay, so here we go. So here we go with this one. Negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. So this is going to carry a negative with it against that. So I'm going to have negative 4x to the fifth. Here I'm going to have negative, negative, takes positive, times negative is another negative. So this is carrying a negative sign. With a positive 12 is going to go negative overall. And then negative against negative is going to be positive. Now, again, if this matches this, spot for spot, sign for sign, everything, then it is an even function. This does not. So it is not even. Okay, so we know that right now. Okay, to check and see if it is odd, okay, what you're going to need to do is you are going to need to factor a negative out of this, okay? So if I factor a negative off of this, it's going to leave me with that 4x to the 5th. If I factor a negative or divide a negative away from here, it's going to turn that to a positive 12x cubed. If I do this positive 9x divided by negative, it's going to turn it into a negative 9x. Now, if what's in the parentheses matches the original, spot for spot, sign for sign, everything, and it does, then this is an odd function because it's negative the original function, which is what the definition said, okay? So now, I've shown you an even one, I've shown you an odd one. Let's look at one that doesn't do either one of them, just so you see how this process works. So again, the idea here is if it is an even function, then we say that it's even and we move on with life and we're done with it, okay? If it's an odd, if it's not even, we're going to check for odd. If it's not odd, or if it is odd, we're going to take the exit for odd and we're done with it. If it's neither one of them, then we just specify that. So x to the 5th plus 1. Okay, so here's my function. So first thing we're going to do is f of negative x. So it's going to be negative x to the 5th plus 1. So negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. So this is going to go to negative x to the 5th plus 1, because there wasn't anything there. Again, I'm looking. Nope, it doesn't match because that first term is negative and it's not. So we are not even. Okay, so then we'll try to factor or divide a negative out of it. So it's going to take that back up to x to the 5th. Positive 1 divided by negative is going to make that negative 1. Again, I'm looking at what's in the parentheses. If that matches the original, spot for spot, sign for sign, and it does not, so it's not odd, then this one is neither. Okay, so now I want to talk to us about graph picture wise. Okay, and so graph picture wise, when we talk about even and odd functions, okay, so even functions are symmetric with respect to the y-axis, okay? And so what that means is they will fold in half on the y-axis. So a couple of examples. Cute little parabola. It folds in half nice and pretty. This cutesy little W shape. Again, I can put a fold line right here on the y-axis and it will fold in half. These two are now even functions. Okay, those are both even functions. Now, an odd function is symmetric with respect to origin. Okay, now origin symmetry is a little bit different. Okay, it's not a fold in half thing. I don't fold it in half either way. So this is an odd function. Okay, and the way that origin symmetry works is you put a push pin right here on the origin and you spin the thing 180 degrees, so a half a turn. And some people can do this whole graph at one time in their head and they can spin it. Others, though, have to do it in parts and pieces. So what I do is I'll take like the top half and I'll rotate it half. This piece is going to line up on this piece. So that means it is symmetric with respect to origin. The bottom will rotate up and match up onto that top half. So it's 180 degree rotation on these, okay? So that's odd. Now, a couple of examples that are neither. If I take that parabola and it shifts, this is neither. Because again, that y-axis is the fold line. This does not have another U-shaped thing over here. This is neither. This graph, if it is shifted someplace else, okay, if I put my push pin right there, I am not going to match up. Okay, so this is neither. Both of these are neithers. Okay, so they can take a shape like this parabola shape or this kind of little S-curve shape, and they could use them that are normally, this is traditionally even, this is traditionally odd. But if it's moved or shifted, it is no longer an even or an odd function as far as respect. This helps us out if they give us a graph picture and I don't have an equation that I can run that f of negative x through.